I thought I would go with the easiest one on relative extrema to start with. And then if you had a chance to look through the homework, there's a whole bunch of different style of questions. And so I figured I would try to do a couple regular ones, like one easier, one a little bit more difficult. And then after that, I'd kind of work on some of the other style questions so that we kind of knew what was going on with them. So finding a word increases, decreases, that should immediately jump out to you that that's talking about derivative. Even if you see relative extrema, that'd be like max and min, so that should, hopefully after a little while, make you think derivative as well. So we'll start by just, oh, that's not a marker. Let me know if it's easier to read today. I'm going to try not to use the calligraphy marker. So I'm wondering if that kind of makes it sloppy when you write small. It has better, the calligraphy marker has better error correction, like it's not choppy, but if it's harder to read, that's not as good. I've definitely been noticing that the writing on these small notes has been really tough. So, okay, so we've got derivative. Magdalene, what do we do with the derivative?
We said it equals to 0.
Okay, good. That was a good fallback answer, even if you didn't know where we were. And then we also look for if it's undefined. This one's not, just because it's a polynomial. And there's different ways to solve this one, but I'm going to factor it out because they both have an x. Fernanda, do you remember what these numbers are called? Good, very good. Now there's a difference between critical numbers and critical points. These are critical numbers, and all that does is it tells us something happens in our function at those two spots. If something is a critical point, that's by taking the x values and putting them into the original function and getting an actual point. Now, every critical number isn't necessarily a critical point. This one will be, just because this is a super, like, not much happens with this function. It's just a cubic function, so it goes up, down, up. If you get functions that have vertical asymptotes or sharp points, just weird things going on. This is kind of where I sort of disagree with the answer key. I can't remember which question it was. One of the questions asked you to find critical numbers, and the ones that were undefined, I believe if I remember right, in the answer key, it said they weren't critical numbers. So like, let's say our derivative was divided by x. In that case, x couldn't be 0 because it would be an undefined value. X equals 0, I know that's stupid because 0 is over here, but 0 is a critical number still. But if you were to put that number back in, you wouldn't get an answer and it wouldn't be a critical point. So there's differences between the two, and it absolutely can be kind of confusing. And if looking through the notes and the answer keys, the way that you'll see it written is on the next step when the number line is written, in the answer key above each critical number, so we've got 0 and 4, above each critical number, it was labeled with its slope. So some of them had a slope of 0, some of them were undefined. If it's undefined, it was written like this in the answer key. I don't usually do that, but you're welcome to do that if you want, if it helps you. Like, the advantage of doing this is letting you know if it's going to be a critical point or not. Like a zero, a slope of 0 can be a critical point. An undefined slope can't be. Or usually can't be. But that's partially why I don't like writing it, because I usually just plug the number in to find out anyway. Like certain undefined ones can have points, some can't. A sharp point doesn't have a slope, but it has a point. A straight up and down line would have a point, but not have a slope. So I usually just leave them blank, but it's up to you how you want to write it. Okay, I know that was a lot of talking about that, but I got quite a few questions on it throughout the day yesterday on that topic, so I figured I would kind of bring it up to everybody. Who should we go with? Andrew? What do we do now?
You test the values in between the numbers and on this side.
Okay.
So if you do x equals 1,
So you're going to do 1. So that's in between them?
yeah. And then that's the negative number.
Okay, so f prime of -1 is negative?
And then if you do
Wait, no, that's positive. Oh, I wrote -1. Okay. I heard you say 1. My brain didn't put it together. That's still negative, isn't it?
oh yeah, I guess.
Okay, did you say +1 or -1? I'm doubting myself now.
Positive.
Okay, that's what I thought. -1 would be a positive answer, because -1 would turn this to +12. I'll give you the benefit of the doubt and say that you were thinking about -1. So positive, negative.
And then if you did like x equals 5, that'd be positive.
Okay. Here was the other question I got asked yesterday, which I get asked every single year. If you figure out 1, can you just automatically write the rest of them because they usually alternate? Yeah, the answer is no. Most of the time they do alternate. And I'm going to guess this is 90% of them. But they don't have to. And on tests and on AP tests, they almost always will pick the weird ones that don't, just for that purpose. So if you get it to alternate, sure, fine. I wouldn't even use that as a clue to think that you're doing it right or not. Okay, Luke? What, is there anything particular we would do from here? Or anything I should do? Doesn't matter, I'll let you choose.
You write the values for the increase and the decrease.
Okay, so positive slope means,
It's the increase.
okay, and you can write the word increasing, you can draw a little line. There is no correct or incorrect way to draw this chart for yourself, especially because it can't be used as like official work. So this chart is just to help yourself out. Write it, draw it, however makes sense to you. But perfect. So negative, positive. Caden, what? I can't remember who I even called on for this one. It might have been Andrew. I think he told me to just start plugging numbers in right away, which isn't necessarily wrong. One thing I usually do before I start plugging numbers in is I write the intervals up on top, because otherwise it's kind of easy to, I don't know, get screwed up with them. Do you think you could help me figure out the intervals for this number line?
What do you mean?
Right here. What would be the numbers where it begins, ends?
So I negative infinity to 0.
Okay, good, very good. Is it always going to be negative infinity?
No.
No. If it's kind of annoying. If they don't give you a restricted domain, you're kind of assuming that it's negative infinity and infinity. Some functions will give you specific values, usually trig ones, and then it'll say like 0 to 2 pi or something. But so it's normally going to be infinity to infinity, but It doesn't have to be. Okay, how about the other two?
0 to 4.
Good?
And then 4 to infinity.
Good. And the main reason I wanted to put these up here is because these are going to be our answers for the intervals of increasing and decreasing. Apurva, did I call on you? Okay. Do you think you can answer the increasing, decreasing one?
Yeah.
Okay.
So on the intervals, negative infinity to 0, or the 4 and infinity, it's increasing because f is smaller than 0, and f prime of x is bigger than 0.
Perfect. I'm not going to put the official answer up there, but yeah, that's good.
And then it's decreasing on their
Positive 4.
Or, yeah.
Yep. No, good. I don't know. Who have I called on? Grace? Anything left I have to do? You could read the directions if you need to.
Oh, yeah. It's on the relative.
Good. Very good. Relative extrema. Any thoughts on how I do that? What makes something a maximum? Do you remember how to do? Good. So looking at our picture, increasing to decreasing. So this x equals 0 should be I don't know, what color should we go with? Purple? What the heck? This is a relative max, we think. So we'll put a question mark. If we can find an actual point, it'll be a relative max. If we can't find a point, then it's just nothing. Like if it's a vertical asymptote, you won't be able to find anything. So it'll just be nothing. So I'm going to plug 0. Where do I plug 0 into? Yeah. Plug 0 into the original function to find out the actual height of the point. So 0 minus 0 plus 15. Because I found a point, it is no longer a question mark. Okay, very nice. Ethan, any thoughts on this one down here, if this is something? Okay, so we think it might be a relative min, and we find out by putting, oh, that's going to work out badly. Okay. We're going to put, what number are we going to put in the original function? 4. Good. And I'm only saying these because these are usually the questions I'll get over the years, like forgetting which number to put where. So 4 into the original function, so 64. Oh, God. 64. So this is a negative 8? So 7? Somebody definitely should check me on that one.
Negative 17.
I was spot on. Negative 17.
Yeah.
I'm going to blame it on being sick. Oh, yeah. It'd be 2 of the 16s in the negative. Okay. I don't know. Sierra, is there anything else we should do? You don't know? So I'm asking these questions because when you start doing questions that have a lot of information, I get a lot of students that aren't sure when they're even supposed to be done. Like, you kind of get lost in what you're trying to do. What were we supposed to find in the first place? Okay, so relative extrema. Did we find relative extrema? Yes. Okay, that one is done. It also asks us to find something else. True, before relative extrema. So we had to find where it was increasing and decreasing. And we did that. We did that to start with. Those were the two things we were asked to find. To check your results, normally I'd agree with that. I would hope a lot of you would know what the general shape of this looks like without even graphing anything, just because it's x cubed. So I would bet a lot of you know that it looks like that. You don't have a clue where, you just know it looks like that because it's x cubed. And that's what our information told us. Up, down, up. That's what we got. Up, down, up. Okay, I don't know. I took this easy question and I wanted to go over it very thoroughly because this is basically the entire section. Like this is everything from the section in this one problem. Anything up there that maybe you had trouble with and you weren't sure why we did it? Like maybe you're not sure why I don't know. Are we going to pretend everything is all good? Okay. And I know some of you are pretending, but look, okay. Why don't you guys try number 6? See if you can, this is the same directions. Find increasing, decreasing. Find relative extrema. And I don't know why, but extrema just sounds weird to me, so I always just call it extrema. It's like L'Hopital's. I've heard it like 4 different ways. Feel free to help each other out and work on it together.
So it's x squared. Yeah, that's one. Yeah.
One? Yeah, that's what I saw before.
So is there just one point?
Mm-mm.
Oh, I guess it says it's all at the top.
I wanted to make sure that the derivative was up there and solved so that the downside of critical numbers is if you figure out the critical number is wrong, then your entire number line and everything from there is not necessarily correct. It's going to make correcting this quiz test a beast for me because they're so wide open. So the derivative, I'm going to guess a lot of you figured out the x squared minus 1 over x okay. Frequently, if you have regular polynomial terms like x squared, but then you also have a rational term like 1 over x, if you're trying to find where it's equal to 0 or undefined, there's different ways you can do that. The easiest is if you make everything one big fraction. And the reason it's going to be easier if you make it one big fraction is because the top of the fraction equal to 0 is where the zeros are. The bottom of the fraction equal to 0 is where the undefineds are. Say it again?
Did you mean to write x cubed?
Yeah, so I had the common denominator, x squared, by multiplying it by x over x. So then that's where the cubed came from. You absolutely could have solved it from right there as well. So if I do x squared minus 1 over x equal to 0, then I would probably add 1 over x to the other side, multiply both sides by x, and cube root of 1 is just 1. And then you would have had to look for undefines on its own before you find the zeros. So right here would have been the undefined at 0. This way isn't bad. It seems like it's easier to forget things. So it's usually recommended you try to make one big fraction if you can, like if it's feasible or not a big deal, because having a rational expression is easier to find the answers. But they all work. So You know, if what I wrote in green made more sense to you, you could certainly do that. Okay, I'm gonna guess it's probably okay for you to finish the problem after the critical numbers. So that's gonna entail you making the chart with the slopes, increasing, decreasing, all that kind of stuff. Okay, I should probably stop before you get too far. Did a lot of you make the number line with 0 and 1 and then test 3 separate regions? Okay, did anybody not? So I picked this problem because it's kind of an odd one.
Doesn't it not exist as zero?
Yeah. It would seem to just make sense to just make a number line, put 0 and 1 on there, and then go from negative infinity to infinity. And that absolutely makes sense. The problem comes in the original function. You're kind of supposed to check if there's any values you can't use to begin with. And if you guys remember logarithms, you can't put a negative number into logarithms. I'll take that back. You can only have positive values in logarithms. Like ln of x means log base e, and whatever number is in this spot, so I'll put 0, which you can't have. What this would mean is e to what power is 0. And you can't take something to a power and get an answer of 0. You also can't have negative numbers here, because you can't take something to a power and get a negative answer. So when you have logarithms, it has a domain restriction, even though it didn't say so. And in the original problem, only numbers greater than 0 can be used. Yeah. So then that would be called a domain restriction. Because of that, that value doesn't even matter. Domain restrictions apply to the derivatives as well, even if the derivative doesn't appear to have the same restrictions. If you can't use it in the original function, you can't use it in the derivative as well. So because of that, this x can't be 0 gets thrown out. It's not even a possible number to be used. So your number line should, there we go. Your number line should start at 0, and actually technically after 0. And then there will only be one critical number. Now, originally I picked this question because what I liked about it was you had an undefined value in the derivative, but in the original function it was semi-okay. That's usually going to indicate a sharp point. On this one it didn't matter because you couldn't use it anyway. Oh, and that's even worse, because now we have to plug a number between 0 and 1 in. Ooh. There's no good number to pick there. Let's just pick 0.1. Point 0.1 cubed be a 1/1000th. Divided by 3 would be 1/3000th. So I'd have one. You can use your calculator in this too. This one probably wouldn't be one where you'd be asked to do it by hand. So this would be 1/3000th minus ln of 0.1 is a huge negative answer. So this would be a tiny number minus a big negative answer, which would make a positive slope.
Why'd you add that into the first equation?
Yeah.
Oh,
Why'd
God.
you do to the derivative?
Thank you. You know, this is why I have trouble talking and doing things. Good save. I plugged it in the original function. Derivative 0.1 squared to be 1/100th minus 10, because 1/110 would be 10. So 1/100th minus 10 would be a big negative answer, or just negative. And then we can pick a regular easy number like 2. 4 minus 1/2 be positive. So decreasing, increasing. We only have one possible relative answer here. It looks like it should be a relative min. I'm going to plug 1 into the original function to figure it out. 1/3 minus ln of 1, which is actually 0. So there's my only relative extrema. And increasing, decreasing intervals. It is decreasing from 0 to 1, increasing from 1 to infinity. So I'll just tell you ahead of time on the test. This test is traditionally where everybody feels like they do horrible. And that's because for a lot of you guys, your mental state is you feel like you only do well on a test if you get them right. But I need you to understand that these questions have so many parts to them that even if you don't end up with the final correct answer, it doesn't mean you're not going to do well point-wise. Just like from the very beginning, if you do the derivative wrong, well, everything's automatically incorrect after there. But if you do the rest of the problem right, from your incorrect derivative, I give you credit for it, like if you do the correct steps. So like a question like this, I mean, like there's so many different places where you could go wrong and make a mistake. Every little part is kind of counted as a whole. So if you just make one mistake, but it throws off your final answer, you're still going to do well on the problem. And just over the years, every single calc test, that's what everybody seems to judge by if they do well or not, is if they got the correct final answer. Like immediately after every test, I hear everybody trying to say what they got as the answer. Well, doesn't mean you got it right or not. But. So know this ahead of time. Don't feel dejected once you take the test. If you have the steps down, you'll be good. I think today's normal day, right? So is this bad that I don't even remember what normal time is? 28. Oh yeah, we got a lot of time. Here it is. I'll go down to the directions, but I wanted to do number 11. Problems 10 and 11 says use the graph of f prime, so the graph represents the derivative, to identify the intervals on which f is increasing or decreasing and estimate the values of x at which f has a relative max and min. So we're basically finding the same thing as the previous question. Find where it's increasing, decreasing, find the relative extrema. But we're going to be finding it from a picture of the derivative. Poyraz, do you want to help lead us?
Sure.
Okay. What's the first thing we did when we're trying to figure out the first derivative test?
We normally set like find like a derivative equation.
Okay.
You don't really need to do that because you have a picture of the derivative.
True, but we should probably still go through the work of figuring out the same info, even though it's told to us. Okay, so where would be the critical numbers on this picture number on number 11?
So you're gonna have one like -1
Negative 1, how come?
because it's a relative min.
Ah,
Where it's
so are you going to say negative 1, 1.5, 2.5?
sure.
Oh, well then I don't want to cut you off. Where else were you going to say?
I was just gonna say that like those points would be like the critical numbers because those would be points where the slope is 0.
Actually, no. Your idea is right. If this graph was of f of x, then you would be looking for where the slopes are 0 by looking where it's flat. Yep,
So that's
perfect. Because this graph represents the slopes already, this is a critical number, this is a critical number, because this is where the slopes are 0. F prime is equal to 0. So these are critical numbers. So you had the perfect reasoning. I mean, you were saying exactly what we were looking for. And it's really easy to overlook, and so that's why I wanted to pick this question. Okay, so should I make a number line? Would that help? I don't know if that would help you or not. I can. If I make my number line, I've got 4 spots on it. -2. You know what? I'm not even going to put them even intervals. I'm just going to number them. That way I have enough space to write. This one looks like it does go all the way to infinities, but we don't technically know. We're just going to assume that. Okay. Who haven't I called on yet? Neil? Any thoughts on what we do next?
You should find the derivatives in between the critical numbers.
Okay, so find the slope
Between the
in the intervals. Okay. How do we do that from the picture? But what you said was perfect.
You should probably set the number first, so like between -2 and 1, pick 0, and then if you go to the graph, you find that 0, it's -2.
Okay, so that is a negative slope. You don't sound super sure. Are you unsure as if you're correct, or?
I'm unsure if I'm
Oh, okay. Honestly, everything you said was perfect. That's 100% correct. You picked a number in that interval, and you checked f prime of 0, and since this graph is f prime, the answer is just the height. So f prime of 0 is -3. So that was perfect. What I'm going to do is I'm probably going to just write directly on this graph. I don't know if that'd be easier for you. What do numbers above the x-axis mean? Positive slopes. So this section is increasing. I can't write sideways on this thing. Positive slopes mean increasing. Negative slopes, decreasing, which is actually what we just wrote on that number line. I'm trying to show you different ways of looking at it, I guess. If this number line makes more sense to you, just because then it's kind of like consistent with what you've already been doing, you're welcome to keep doing that. If it's easier for you to just look at a picture, you can do that. It's kind of up to you. Maria, I don't think I've called on you. I always forget the people close. Do you think you could just keep answering more stuff out of this, or?
Yeah.
Okay,
So, do you want like between 1 and 2?
sure.
So that part's, the graph is above the x-axis.
Okay.
So that'd be positive.
It's barely above the x-axis, but it doesn't matter how far above. It's positive slopes.
And then between 2 and 3, it's below, so it'd be negative.
Okay, good.
And then from 3 to infinity, it'd be positive.
True. We also forgot this section over here. Okay, we've got a whole bunch of sections. Jack, have you gone?
No.
All right.
Now we need to figure out where it's increasing and decreasing.
Did that?
And
If you want, I can, a positive number up there represents increasing, or, so you can either write the word or draw it.
and then estimate the relative min.
Oh, okay. Now it says estimate because we're not actually going to be able to find the y value. So what we're going to be able to do is figure out if it's a relative min or max, just the x value of it. Okay? Do you want somebody else to do that, or do you want to do it?
Sure, someone else.
Oh, okay. Who have I called on? Luke?
Okay, so,
You guys sound so unsure of these answers.
I know, because we haven't looked at graphs in so long.
I could just erase this picture at this stage and just use this chart that we made, and we don't need a picture to figure that out. I guess before you start answering, the only thing that could really screw this up from here on out is if there was an x value we couldn't use. According to this picture, it looks as if we should be able to use any x value. Like there's no undefined things, there's no gaps, there's no holes, there's nothing there that we can't use. So we don't have to worry about if it's defined or not.
So it's just relative, right? So there's probably many.
Yep, what's that one going to be?
So that's going to be a max.
Yep, it's at the top.
Um,
And we're just going to say the x value. So we can't give the point because there's no way to know it. And that's why the instructions are written kind of weird. There's no way to actually find the point.
and then that's going to be a relative mean at x equals 1.
Sometimes you'll be asked to find just the x values to make the problem go quicker as well. Like that's a common test thing.
Relative max to relative min.
Good. The increasing intervals would be from negative infinity to negative 2, 1 to 2, 3 to infinity, and then decreasing intervals from negative 2 to 1, and from 2 to 3. This one has a lot of stuff. Does this feel a lot harder to do it from this picture? Or I should say from the derivative. I bet if this was just f of x, you could probably answer it everything like immediately. Like you would be able to look at this and say decreasing, increasing, decreasing, increasing, min, max, min. But it doesn't stand for f of x. Should we go to the last one? Okay. Otherwise, feel free to ask questions away. I don't even know if maybe this is a case you guys are having trouble even knowing what questions to ask. Let me zoom out because there we go. I can get the whole graph on there. Sketch a graph of a continuous function f that satisfies all the stated conditions. Ooh. Ooh, Hannah, you haven't gone yet. Can you help me start anything up here?
You could label some of the points, like, I think 0 equals 1.
So that's a point. Okay, f of 0 equals 1. So the point 0, 1. F of 2 equals 3. So those are just points on the graph. Okay, did that, did that. Do you want to keep going? Do you want me to pass it on to somebody else?
You can pass it on.
Oh, wow, that was so nice of you. Emma? No?
I don't really know how to do it.
Oh, we didn't do anything.
Well, if it's f prime of 0, doesn't that mean it's slow?
Good.
But if it's equal to f prime of 2,
Oh, they were just being lazy. They didn't want it. So if you look at the way this one's written, they didn't want to write it twice.
oh,
It's,
so those are just the critical points because the slope is 0.
yeah, so it's saying f prime of 0 and f prime of 2 are both 0. Yep, that's just kind of lazy way of writing it, which is definitely something I would do. So, so it's saying it's got a slope of 0 at those two spots. Now, luckily, like we could draw a slope of 0, except the problem is we wouldn't know where to draw a slope of 0. But this one specifically, they picked the exact same points that we already drew. How do I kind of... I'll just draw it. What you said was perfect so far. You said they both have a slope of 0. I'm just going to put a little tiny flat line there, indicating that it's going to flatten out there. So slope of 0. Good. You want to keep going or want somebody else to go? I see. Kylie, did you go? Okay. Do you want some assistance?
Yeah.
Oh, okay. F prime of x is less than 0. What does that mean? Negative slope. Okay. So that means a negative slope. It's a negative slope from negative infinity to 0. So this whole half of the graph has a negative slope. We know it has to hit this point. So I'm going to draw a negative slope. That's rough sketch of negative slope. And also from 2 to infinity. Okay, well, it has to hit this point at 2. So from here, it's also going to go negative. And then f prime is greater than 0 would be going upwards, increasing from 0 to 2. And the thing about the points is they help us and aid us because we know our function has to go through those spots. And it's telling us it's going upwards from that point to that point. So this is a rough sketch. If you wanted it to look nicer, you certainly could. We would have no idea how steep the slopes are. We would just know that it looks roughly like that. How'd that go? Does it make a little more sense now that we went through one of them? Do you think you could draw the second one? Which has more stuff. Why don't you try 13? See if you can make a good rough sketch of 13. f prime of x is less than 0. I wish this was a little more specific. I can already tell what the idea is supposed to be. Instead of saying f prime of 3 does not exist, which isn't wrong, there's different kinds of doesn't exist on slopes. So I kind of wish this would have just said that this was a vertical asymptote. I guess theoretically it could be a sharp point. You know what? It could be drawn either way. There's going to be multiple correct graphs we can draw. And I guess as long as we draw a function that meets all of these conditions, it's correct. So f prime of 3 does not exist, to me, would either be a vertical asymptote or a hole or a sharp point. One of those three things. Now, if I sketched everything else up here, except I didn't sketch the concave part. Do you guys remember what that meant? So concave down means it's curving downwards. It would look like a U. It doesn't have to be the entire U shape. It just has to be curving down. So sometimes that could be the left-hand side, that could be the right-hand side. It just has to be curving down. So if I'm looking at the rough sketch of this picture and it says it's curving down everywhere but at 3, I'm going to kind of expect that that's going to look like, ugh, that's bad. This is really hard to draw. I'm going to expect that it looks like this, like a curvy V. That's one possibility. Another possibility is if you drew a vertical asymptote at, okay, I missed 3, but we'll pretend. If you drew a vertical asymptote at 3, then both pieces of that function could kind of be going next to that vertical asymptote. And both of those would be correct given that info. That one's a little bit harder. I mean, I had you guys try it, but I wasn't even looking at the details ahead of time.
The concave down part, does that only mean that like going up to 3 from the left, the graph has to be concave down because the right side of the graph is not concave down? Or no, it is.
Yeah, so this is kind of strange notation, even though it's right. It's saying it's concave down everywhere but 3. So 3 is the only place where it's not concave down. And it's not telling you it's concave up, it's just not concave down. And so that's kind of why I'm thinking it might mean a sharp point instead of a vertical asymptote. But I would give credit for both of those because they would both be right. I know in the past, drawing curvature is the hardest for most students. Like this seems weird to you probably, that those are both curving down. Even though it kind of looks like they're both going up, you know, like just feels like it's going up. Okay, I'll stop there. That took up the whole hour. I wasn't trying to do that.